Good morning, everybody. You're welcome to Stanley's Online Chemistry Solution today. Now, we're looking at an interesting topic today, illustration of coordinate covalent bonding, that is dative bonding. We want to illustrate it to see how it happens. Now, you remember dative bonding, the combination of covalent and ionic, sharing of electrons and transfer electrons, like dashing of an electron, right? Now, good. We'll do an illustration with the what? Formation of what? Ammonium. Formation of ammonium. You know your ammonium, right? Addition of extra hydrogen atom. Yes, we can call it hydrogen atom. Now, you understand this, right? Good. So, now the question of the reaction can go like this: ammonia NH3 plus hydrogen plus a proton. Let's call a proton now with chemistry terms to give us what? Ammonium. Now we'll be looking at what happens to this, and inside the atom, what was happening for this to be formed, right? This is what we'll be looking at. Now, you remember your nitrogen? Your nitrogen is what? Atomic number 7, right? That is, nitrogen is 7. That is 2 plus 2 plus 3. You understand what I mean? That is 1s2, 2s2, 2p3. Two shells. First shell only have 2 electrons. Second shell have 5 electrons. 2 for the s orbital that is already filled completely, and the 3 remaining for the what? P orbital singly filled. That is, you have something like this now. This is something like this. Say this is the internal one, right? Now you have something like this. You have something like this now. Let's go with something like this now. Now this is the 2s, right? It is already filled. Abi? Now this is the p, 2p. They are each singly filled, right? Now, because this thing remains three electrons to be 8. So the hydrogen, the 3 hydrogen, you know hydrogen is 1 1. So they need 1 1 1 to share and become 2, right? So hydrogen came here. Hydrogen came here. Hydrogen came here, right? It is now 3 hydrogens, right? Do you understand? It is now 3 hydrogens. So hydrogen is complete, is happy that each of them now has stability, 2 electrons, right? Nitrogen is happy that it now have 10 electrons total, right? That is now 8, the outside one. Good. So that is why you have NH3, right? But then when a proton comes, when a proton comes interacting with this, tending to be joined to it, right? This is a proton. Now, why this is a proton? According to Arrhenius, this is an Arrhenius acid, right? Arrhenius say that an acid is a hydrogen ion producer, right? Hydrogen ion producer. So this is Arrhenius acid. Do you understand? Good. So it's an acid, hydrogen ion, a proton, but it has an empty shell. It has an empty shell. Hydrogen, the shell of hydrogen has what? 1 electron. Now for hydrogen to carry positive, according to bonding, when we see positive, it means what? Dashing, giving out. An electron was given out. So by 1 plus, so 1 electron was given out. So hydrogen now has no electron again. It has so, but what made this atomic structure to still be possible? This is something like this. What made it to still be possible is what? Because of this charge. Normally, if the atom is empty, the atom is supposed to collapse. There is nothing again there, right? The atom is supposed to collapse. Even this nucleus itself, there is nothing in the nucleus. You understand? So it's supposed to collapse, but because of the presence of this thing now, it is existing, right? Good. So there is no electron in it for you to go into this bonding, but you want to go into bonding. That's why it is a dative bonding, not a covalent bonding, because nothing to share. But then if you come to the nitrogen, the 2s2 is a lone pair. It is together, a lone pair, 2 electrons together, right? While the p is at 1, where the hydrogen configured into. Good. So one thing about a lone pair is called a Lewis acid. Lewis acid are species that can give you electrons. That is a Lewis acid. That can give you what? Electrons. Arrhenius acid is a species that can give you a proton. Lewis acid can give you electrons, right? Good. Now, This one now is attached to the lowest acid, the lone pair. Normally they're supposed to bring one electron and share and bond, but this one have nothing. This one already have two, so it is not a problem for you to bring in hydrogen, empty hydrogen. When you bring in the empty hydrogen, the hydrogen will leave by its lone pair, the lone pair of that S2 nitrogen. Are you following me? Good. So it will leave by it. This is a form of, if it's in biology they call it a commensalism. The nitrogen now becomes the commensal. It is not losing anything. It is accumulating another that needs something from it. Do you understand? So when you now see NH4, these four hydrogen, you can boldly write it 4 because of what? The fourth hydrogen is now an atom. It is now acting as an atom, no longer as what? As a proton, right? Do you understand? It is acting as an atom because it is legally binded now and shared to what? The S2 orbital of the nitrogen. Do you understand? Now, why we still put the proton there, the charge there, is because of what? This whole thing is a reaction system. This whole thing is a reaction system, and you cannot throw away the charge. If you test this reaction system now with anything that can test it, it will test charge electrified because of what? That charge, that proton charge. Do you understand? So that is why you still put the charge here. But this fourth hydrogen is there. It's now an hydrogen. It will now have 4 hydrogen atoms. It is well attached and bonded to the nitrogen structure because of what? The lone pair of what? Of the hydrogen. Do you understand what the chemistry that is happening there? Because of the lone pair. Now, if you want to count, for you to say that it is over now, it is not over. If you want to count now, there is no electron in that hydrogen. For you to say that the number of electrons are exceeded, there is no electron. Do you see why it is the chemistry is still correct? So, but it is legally staying in the structure just because of the what? The lone pair of the nitrogen, the S2 nitrogen. So this is how ammonium is formed, and it is what? It's charged. Ammonium is charged because of the proton that came, the charge that came with the hydrogen proton. I hope this is very clear. See you in the next video.